Okay, a couple more examples computing derivatives. This is number 16 from the book. Actually, this is a good one to do because it's going to use about every rule we've talked about in this section. Okay, so the function is given to us as y equals 2x cubed minus x squared plus 3x minus 1. Okay, so we're asked to find the derivative. So probably the first thing we want to do is write either y prime or dy over dx. This is the thing we're looking for. Okay, and how are we going to find it? Well, we're going to find it by applying this derivative process to the function, 2x cubed minus x squared plus 3x minus 1. Okay. Now, again, as I said, this one's going to use just about every rule we've talked about, so you have to be kind of careful, and you want to use them efficiently. And by the way, as you get further into the future, you'll find that you can do a lot of these rules all at once. Okay. Now, first rule we need to think about using is the sum rule and the difference rule. Actually, very much the same rule, but one deals with sums and differences. You see, this function whose derivative we want to find is many simpler functions added and subtracted together. So those rules, the sum and difference rule, okay, tell us that when we're adding or subtracting functions and asked to compute the derivative, we can instead compute the derivative of each one separately and then add or subtract the results. So it's an important way of breaking down the problem. This big derivative is really just the derivative of 2x cubed minus the derivative of x squared, okay, plus the derivative of 3x minus the derivative of 1. Okay, so you see what I did there. I took the derivative of this sum and difference and wrote it as a sum and difference of separate derivatives, because each one of these littler functions, smaller functions, is closer to something you can apply a rule to. Okay. Now again, before I actually compute derivatives, I'm going to use a rule a couple more times here, and it's that constant multiple rule. One of the main rules we use for computing the derivative is the power rule. But if you look at, for instance, this term, I don't have x to a power here. I've got 2 times x to a power. So that 2 needs to be factored out. That's one of our rules. Okay? If we have a number, a constant, times a function, we can factor the constant outside. Okay? So this is going to be 2 times the derivative of x cubed minus the derivative of x squared plus 3 times the derivative of x minus the derivative of 1. And notice I used the constant multiple rule again here to factor out that 3. Okay. Now, inside each of the derivatives I have to compute is either x to a power or just a constant. What other 2 rules do we have? We have a rule for taking the derivative of x to a power and the rule of finding the derivative of a constant. Okay. So this is 2 times, well, what is the derivative of x cubed? Well, the power rule says bring the power down and decrease it by 1. So it's 3x squared. Okay. Minus, well, we can go ahead and compute the derivative of x squared. Just the power rule. The power comes down and we decrease it by 1. Okay, so that's 2x to the power 1, or just 2x. Now here we've got 3 times, yet again the power rule works. 1 times x to the power 0. Now x to the power 0 is actually just 1, so I can just leave this as 1 if I like. Okay. And the derivative of a constant is 0. That's the last rule we have. Okay. So this is my derivative. All of the derivatives have been computed, just a matter of finding the answer. Okay, so again, normally I would write this below, but because I'm running out of room here, the final thing I can say now is, okay, so y prime, the derivative of this function, is 6x squared minus 2x plus 3. Okay. Now, relatively, not that much work. Definitely a lot less work than using that big limit definition of the last section to compute the derivative. It would have been just an amazing amount of writing. Here we got by pretty quick. And yet this is still a pretty complicated function we started with, so these rules really are pretty powerful.